Good morning, everyone. Welcome to our third day. We haven't met before. My name is Ruben Delgado. I'm a program manager on the product team. The first day I was in the sales track, and then yesterday was a prep day for today. So I'll start out by talking about store database and enhancements. Are we frozen? Did you freeze the screen? Oh, there we go. Okay. So for this session, I'll go through just a basic feature overview, introduce people to the concept of a store database if you haven't heard of it before, and then I'll discuss some high-level workflows, supported topologies, a database utility, which is a new thing for this release, what an offline database is, database synchronization, changes to POS, some of the supported and unsupported offline functions. I might actually skip that slide because it's pretty minimal. And then supported databases and what was out of scope. So sort of from an overview, the goal of this feature was to basically keep a retail store open all the time. And one of the things that's really important is to have the ability to function when your main database isn't available. So for a store database, we introduced this thing called the offline database. So being the first thing that's important to retailers is taking money, we're kind of taking steps to make sure they can always conduct transactions. Another thing that was kind of a result of this feature is we really reduced the load on Reconnect, and I'll show you why. Also, as you've heard a couple times before, there's this notion of the single version of the truth, and the store database ensures that. And then also, as a result of this feature, we've enabled some scenarios around like sidewalk sales or trade show sales where you could take maybe a laptop that has your point of sale and store database on it and go off-site, perform a bunch of transactions, and then come back and sync them to your store database. And just kind of another result of this feature is that we've reduced a lot of some of the administrative overhead that was associated with our previous supported topology. So some of the terms I'll be talking about today, first is store database, and that's you can think of that as a central database within a store. That's the primary database used to save transactions, store master data, and link point of sale terminals within the store. An offline database is a database that's used by the point of sale, and that's local to your point of sale terminal. So that offline database essentially stores copies of the master data, and it's used when that point of sale terminal can't access the store database. And this is optional. Next, we have a sync service. So we created a service that synchronizes data, and it's built on the Microsoft Sync framework, and that synchronizes data from the store database to the offline database. And next we have a database utility, and that's a standalone application that creates the databases. So at a really high level, I think you kind of get this, but we have a store database, and point of sales can connect to that store database. And during standard operations, these store databases are reading all of their these point of sale terminals are reading all of the master data from that main store database, and they're writing transactions to that store database. So, and then when we talk about an offline database, you can see on the left-hand side we've got a scenario where you're connected to the store database, the point of sale terminal is writing to that store database, and at the same time the offline database is getting synchronized. And basically that means if any master data is coming down from the headquarters, that's synchronizing to the offline DB. And when if the connection is lost or the stored database is taken down for whatever reason, the point of sale then connects to that offline database. So kind of an overview of how the synchronization happens. We get our master data down from the headquarters, and that goes to the store database. And then as point of sales performing normally and reading from that store database, that master data synchronizes to the offline database. So I think I've kind of covered this. An overview of the sync is just that master data goes into the store database, and then where the sync service happens is between the store DB and the offline database. So let's talk about our supported topologies. Previously, and I think we've mentioned this before, our point-of-sale terminals were sort of islands. Even if they were in the same store, they connected to HQ independently. And what this meant was that you had to have pretty much a complete setup for each terminal within the store. And that's no longer supported. Now you have to have a store database within the store that the point-of-sale terminals can connect to. And as I said before, the offline database is optional. And what this does, and I'll talk about it more, is we're really creating only one connection between HQ and the store in the store database, and that's only one connection needed for syncing master data. And kind of a side point, the point-of-sale terminals, they can still connect to the HQ independently because they use transaction service. So this is sort of for ad hoc during the day type functions where you need to look up a gift card amount or things like that. Transaction service is independent of that. So the advantages, first of all, we really reduced the load on Store Connect. If you can imagine, with our previous release, we had, say we had a store with 10 terminals. Store Connect had to update the master data on all of those terminals. And so we take the 10 connections and that 10 syncs required and take it down to 1 for the whole entire store. And then also we've talked about single version of the truth. And what this means is that our terminals no longer have different data if they're syncing with HQ at different times. They're all looking at the same DB. And so as someone mentioned yesterday, the big thing around that is prices. You want to have the same price on point of sale A as you do on point of sale B. Also, we're enabling sort of cross-terminal scenarios. So because these terminals share a database, you can suspend a transaction on point of sale A and then resume that transaction on point of sale B. Or you can do things like returns within the store and not have to wait for the transactions to sync up to headquarters. So we're really enabling a lot of those scenarios from a cross-terminal standpoint. So what we did was we created a database utility, and this database utility is it can be installed separate from the point of sale. And what it does is perform the database creation. It can create the store database and the offline database. It helps us connect to those databases. And it can be used to configure these actual connections. So it will identify the point of sale terminal with a store number ID and data area ID. And also, this utility is important because this utility runs elevated, and it kicks off provisioning of the databases. So point of sale doesn't have to do this work anymore. Before point of sale, when you launch it, if it didn't detect a database, it would create one for you. And this is kind of a no-no from a best practices standpoint. We don't have to require the point of sale to run as elevated. And so we've abstracted that data creation process and put it in its own separate utility. Oh, and another benefit is you don't need to install the point of sale to create a database. So in a store server scenario, you can just run the DB utility and create that store database. So there are a few issues with the database utility that I need to cover. One thing is that the documentation isn't exactly accurate on creating a store database. A few of you in the audience, we've probably spoken about this. So we're working to update those steps that we have documented for creating the store database. It's pretty minor, but if you follow the right steps, it'll work just fine. So we'll talk about those actual steps in a minute. Also, if you noticed here, and I can show this in the product, but when you're creating a store database, there's a bug where the database utility requires the identification to be filled out for the store database, even if you don't have point of sale installed. So that's fixed in current builds, and that information isn't used, but it's just something that the database utility is looking for when it's closing down and creating that store DB. Another thing is we can do more to identify errors. If someone hasn't done something right, or if there's a problem connecting to SQL, we can give more meaningful error messages. They're kind of generic right now. And so we're going to work to kind of give you more guidance if there is an issue using the store DB. And also kind of something that's not a real life scenario, but something that a lot of you might run into, setting up a one box on a machine that's also a domain controller. This database utility tries to create a point of sale user, and the domain controller doesn't like that, so we'll show you how to get around that. So on the domain controller, you have to disable the creation of this POS user, and it's just a setting in the DB config file, and this is something we discovered setting up our own one-box tests, and so we kind of created a way around it in the DB utility config file. So you can just basically change this create POS user from true to false, change that setting, and you'll be fine. So and I have a lot of information in here. You can go back to the slide deck later and look at it again. So the steps for using the database utility on a one box. The first step, and this is mainly for one box if you have a store database and offline database on the same machine. So in the first step, specify the store server name, store database name, and the identification, which I said is you shouldn't have to do, but you do have to do it. And don't specify an offline database information. So if you fill out everything in the database utility, it won't work. So if you're just creating a store DB, don't fill out offline DB in the first step. So after we've created our store database, you want to run your end jobs and basically populate that store database. And the reason you have to do this before you create your offline DB is that we have, and I'll get into this more later, but the database utility needs to know what tables are synchronizing between the store database and the offline database. And that information comes down from headquarters. And so you have to basically tell the store database which tables are being synchronized before you can create an offline DB. And then after you've run your end jobs, start the offline synchronization service, and then open up the database utility again and configure your offline DB. So just a little bit about the offline database. It's optional, and it's basically a copy of the store database. It has also tracking tables, which are basically copies of every table, and that helps us to keep track of it, and make sure that we have the latest data compared to what's on the store database. This offline database only stores transactions when the point of sale is connected to the offline database, and that's important from a database growth standpoint, because we realize that a lot of you will want to use SQL Express for this. And so that keeps the offline database relatively small compared to the store DB. I mentioned before, it has to be local on the same point of sale machine. And the database utility won't like it if you try to create an offline DB that isn't on the local machine where you're running it from. So we'll talk about synchronization now. The sync service is powered by the Microsoft Sync framework, and it's version 2.1, and you'll see that there are 3 different redistributables there on the download website, and you only need the synchronization and database providers. This works with SQL Standard and Express. Just keep in mind that SQL Express is throttled to 1 CPU and 1 gig of RAM, so you don't want to use it in a store server setting where you have hundreds of thousands of items and a whole bunch of terminals connecting. The sync service has built-in conflict detection and logging, and frankly, we don't take advantage of all of that, but we do some logging there. That sync service is actually created when you install point of sale, and the reason for that is it's only needed on the point of sale terminal. So your store server being the publishing database, or your store database being the database that publishes this information, doesn't need that service. And okay, I think that's it. So at a high level, it's kind of the flow, and you probably get this by now, so I'll probably just click through a few of these slides. But we've got our offline database. You lose connection to your store, and this is a lot cooler in the demo, so I'll probably just kind of jump forward to that. And when you're offline, you can keep using your offline database. And the cool thing about this is you can do things like administrative tasks on the store DB. You can take your machines offline and then work on your store database. Maybe you're upgrading the hardware or doing something like that. It's not an issue. You can keep selling. You can keep taking money. You can keep the customers happy. And also, it makes scheduling these things way easier, so people don't have to do this stuff in the middle of the night. When you reconnect, the point of sale reconnects to the store database, and also the offline database will then synchronize all of your transactions that were performed while you were offline back onto the store database. And we've done this before. If people are familiar with RMS, the way offline worked was we basically replayed all of the transactions in RMS, and they went through basically the business logic within RMS. We don't actually replay the transactions through point of sale. And in fact, the offline service is completely separate from the point of sale. And we did that so they wouldn't be dependent on each other. So right when you go back online, you can start selling again, and you don't have to wait for this process of syncing the transactions. So like I mentioned, it runs as a separate service. You can actually configure the logging levels for that synchronization service. In case you've made some customizations, you want to see what an issue is with the synchronization, you can tweak that logging to kind of help troubleshoot the issue. And then also this sync service runs at intervals. And by default, every 10 seconds, we're checking to see if there's new data, but you can change that interval if you need to. And that can be modified at the HQ in the retail offline scope table. So I just said the word scope. What does that mean? Basically, scopes are sets of data that are synchronized between the store database and the offline database. And those are arranged in scopes as kind of a term that the sync framework uses, so we've adopted it. And we kind of modeled those scopes on the scheduler jobs. So if you can think of how all the scheduler jobs sync different tables, kind of in one go. You've got like the terminals job, for instance. Our scopes are just like that. And we created a job that syncs that information down. It's the 1095 job. So oh yeah, and also there's these sets of scopes are assigned to the offline profile within the store record. And kind of something to keep in mind is we wanted to give partners and customers the ability to modify the information that's synchronized between the store database and the offline database. And you can do that from headquarters now. You can specify, like if you have a new table at the store and you want that to be available offline, you can add that to your offline scope and assign it to the store and then sync it down. Something we didn't do but would be really cool is we don't actually create those tables locally. So you have to actually create those tables in SQL Express or SQL Server. And if you do this and you modify what's being synchronized between the store DB and offline database, you're going to want to re-provision those offline databases, because that will actually go in and create the tracking tables that are required to make sure that your new table in the store database is synchronized with the new table in the offline database. So we have created the ability to switch databases within the point of sale. And this is just a new operation we added to the point of sale. Basically, it's called database connection status. And you can open that up. And it will tell you if you're online or offline. It will tell you when the last time you connected to your database was. And also allow you to make the switch. Now, we also added sort of a status in the point of sale that tells you which DB you're connected to, whether it's your store database or your offline database. And I can show you that too. So if you're conducting a transaction in the point of sale and the store server is taken offline or goes down or whatever, we wanted to kind of make this as seamless as possible. And at first we thought about maybe we can just switch behind the scenes and the cashier never knows it. But that's a little bit trickier than we had time to work out. So basically, if that connection goes down, the cashier will be informed, and they'll have to basically void that current transaction. So they'll void that current transaction, and then point of sale will automatically switch to offline. And the reason we do that... So we'll get to that in Q&A. So just hang on to that one. It's a good question, and we'll get to it later. So now we'll get to the demo. Oh, I'm 3. Oh, cool. Okay, so here in the point of sale, and you can see we have a button configured for this database connection status. Let's make sure I'm on. Oh, okay, so I'm logged into the Seattle store. And on the VM, we don't actually have the Seattle store set up for offline, but the New York store is. So. Let me just bear with me while I log into the New York store here. Okay, so right now you can see I'm currently connected to the store database. Well, you probably can't see that, but trust me, it says connected to the store database down in the status. And if I open this up, it will confirm that I'm on. We call it online. So now I can switch offline and take just a second. Now we're connected to the offline database, and I'll perform a sale here. And we can look at our database connection status just to confirm we're offline. So I'll cancel this, tender my transaction, and then now I'll switch back online. And so before I switch back online, while we're offline, the point of sale, or I'm sorry, the offline database isn't trying to connect to the store database. So we did that because let's think about, let's say you're doing maintenance on the store DB, and so you connect the point of sale to the offline database, but the offline database is taking whatever data is happening on the store database, and it's not an ideal scenario. So the synchronization won't kick back on until we actually tell the point of sale to connect to the store database. So I'll say work online here, and now I'm back connected to the store database. And I'll open my journal. Let's see here. I'll just create my button because I'm not entirely familiar with this layout here. So So here's a journal, and here's a transaction I just conducted while I was offline. So it's already synchronized back onto the store database, and you can return this transaction on the store DB, and it all happens pretty quick. As just before we started, I was looking at an email from a tester here, and he said, with 2 terminals, with the offline database connected to a store database, 1,000 offline transactions with 10 items each on both terminals took less than a minute to synchronize. So that's a pretty good performance for offline. So let's say I'm online, and an issue happens where maybe the online database or the store database has a catastrophic error. I can actually, I'll show you what that would look like or what the cashier's experience would be. So I'm just going to take this store database offline. Okay, now in the point of sale, if I try to say I'm just ringing up items, it's going to say, hey, there's a problem with the database. You need to avoid your current transaction and ring up the transaction again. Now, this might have been more interesting and made more sense if I had an item added to the transaction. But the point is, point of sale, the state of that transaction is an issue when we switch databases. And so to make sure that gets cleaned up, what happens is I'll click OK here, and then void transaction. And this is the only thing you can do if you're in a state where you're supposed to be connected to the store DB and it's not available. So I'll void this transaction, and what that does is it marks in the offline database the transaction number and the fact that it's dirty and it needs to be deleted. That transaction object should be deleted when we connect back to the store database. So wasn't entirely apparent, but now we're connected to offline and we can keep conducting transactions. So you can see here we're connected to the offline database. So now I'll show you the database utility. And because of the magic of that batch job that allows us to launch both the Seattle Terminal 1 and Terminal 2 and New York point of sale, this isn't populated right now because it's looking in a place where we don't actually have a config file with information. But just to kind of show you the database utility, and we'll talk about how that works. We've had feedback that this isn't the most user-friendly thing in the world. It's not the kind of thing that you sit down the first time and it's entirely apparent what to do. But that's why we're here. So when you're setting up the store database, Kim's laughing. So when you're setting up the store database, you can see we've got radio buttons here that allow you to configure the store DB or the offline database. When you're configuring the store database, ideally all you'd have to do is assign a database name and tell it which server to create the database on. But that one step that I talked about when you're creating your store database requires you to toggle to configure offline database and then specify store ID, terminal ID, and data area ID. So that's just, you have to do that to create your store DB. And after you've created your store database, then run your end jobs, turn on the service, then you can come back in and configure your offline database and specify a local server name, offline database name, and then the same information. And this area that says identification down here below, that basically tells the terminal who it is. And that information is saved in the config file for the point of sale. So, and also I mentioned reprovisioning. If you ever have to reprovision your offline database, maybe you added a table or something, you can just open this up and click continue without making any changes, and that kicks off the provisioning as well. So, and we make that, you have to do this because if we just had the service do this whenever it detected a new table, then that's against best practices, and so we make it explicit that an administrator has to come in and do this. So, oh, and I'll show you offline scopes while we're at it. So here under point of sale and profiles, I'm back in the retail node here. You can see I have offline profile. And so I'll open this, and you can see we've got an offline database profile, and these scope descriptions are all just the same descriptions as our jobs for the retail scheduler. So I can also open the actual individual scope and see what tables are assigned to that scope. And from here is where I would add a table to that scope. So yeah, I think that about does it for the demo.